Hi everyone, welcome to a presentation about the Maniskill 2, a unified benchmark for generalizable manipulation. So let's get into it. Why a new benchmark? Hint, it's actually about a generalizable manipulation skills. So the existing benchmarks lacks the followings. It lacks the variation of different tasks and diversification. It lacks the simplified physics, such as a soft body of the objects that being manipulated, and it has limited scope. So what is the scope? It is not too great at rendering the tasks that is given by the user. So we will get into it on how these Maniskill 2 achieves a better high speed on these tasks by locating to CPU and GPU differently. So let's get into it. So Maniskill 2, a unified solution. It has 20 diverse task families, over 2,000 object models, and around 4 million demonstration frames. So this is a really great diversification and a lot of different tasks to be looked into. So what does Maniskill 2 bring to us? So it brings a mobile stationary robot, a multi-arm setups, such as here you can see it has 2 different robots manipulating a single object simultaneously. And we have a rigid and soft body object, such as you can see in the dexterous hand, it rotates the ball. And in the other slides, we will see the pore and the other soft body. We will see the rigid and soft body objects in the next slides. So the first key feature, the real-time soft body simulations. Built from NVIDIA RAP Simulator from scratch, it is a GPU accelerated custom material point method, NPM it's called. And this method allows to do tasks such as scooping and pouring with ease. And as you can see in this demonstration, this is a soft body object in here. It is a liquid, and with this on, you can just pinch it and get this above on here, as you can see on down there. And using a 2 dynamic coupling, NPM and rigid body Sapien simulator. Sapien is a really important simulator on how to use and see the GUI rendering. And robots can interact with the soft bodies as well. So the second key feature is a sample collection for visual RL, reinforcement learning, which is a high-speed version of it. So the render server handles parallel simulation environments by sharing resources for each task, which reduces the memory usage of GPU. So it tries to use less of a memory while computing these tasks. And asynchronous rendering, I talked about it earlier. The CPU is used for calculating the rewards, while the GPU is used for the rendering utilizing the system for the maximum output. So what this does, the asynchronous rendering does, is making the CPU work on a different task and the GPU on a different task to handle a large scale of rendering to be done separately and utilizing the hardware to the maximum. So with just one GPU and 16-core CPU, it utilizes a CNN-based policy to collect 2,000 frames per second. Isn't that amazing? So for the third key feature, diverse task and multi-control. So it gives us diverse tasks with multi-control about the soft body manipulation, fill, pour, hang, pinch, and the write, which are not being done in other benchmarks. And it gives us a precise peg and hole, as you can see in this video. It precisely pegs in the hole, and it lets us utilize the YCB and the EGAD object sets. And another important key feature is that it gives us a conversion of action space. So what this does is making the large data set useful for other approaches. So if we handle action space, generalizable action space, we can use these action spaces on other large data sets to be useful for other approaches, such as tasks and other stuff. So key takeaway and findings. So there are 3 versions that we tested in the article. Sense Plan Act. And Sense Plan Act, pick single YCB achieved a 43.21% success rate, having difficulties within 10 objects. In imitation learning and reinforcement learning, behavior control performed poorly, and RL, reinforcement learning demonstration performed with 54% success rate, although there are still room for. So with RL demonstrations performed with 51% success rate, although still room for improvement. And the best one is here, Sim2 Real. It's with zero-shot transfer policy trained on PIC-Q, achieved 60% success rate, proving potential. So with the Sim2 Real, we saw in the article that there's a 60% chance, or 60% accuracy, not chance, 60% success rate proving potential. So we can see in the future that we could achieve a higher success rate with the Sim2 Real, and there's potential to continue on these findings. As you can see from the Sim2 Real demonstration, in the left side is simulation and real setup for PIC-Q, and the right side we see the motion planning execution results for pinch in simulations and in the real world, and you can see in the initial state and in the latter state. So it gives a promising output on how to use it in the real world cases. As you can see, this is the real world robot. So, in conclusion and future directions, Maniskill is a fast, easy to use, and unified approach for generalizable robot manipulation. So, it's comprehensive and diverse, with 20 task families, 2,000 objects, and both rigid and soft bodies. It's a state-of-the-art simulation, features the first real-time, two-way coupled rigid NPM simulations for realistic body interactions. And lastly, it's promising for sim to real. The physically realistic simulation shows strong potential for transferring learned policy to the real world. So what this does is, not only it's just in the simulation, but also it gives us a chance to perform these actions, tasks in the real life, giving a one zero transfer at a time at any speed. So thank you for listening to me.